to confirm if everyone is hearing me clearly.
Yes.
Okay, thank you so much. And thank you for confirming that. I want to welcome everyone uh, to my lecture today. Of course, this is going to be the last day of meeting in this semester. And what I have for you today, I'm actually going to finish the variant of logistic. I'm going to do that for probably 10 minutes. And after which, I'm actually going to tell you about the final, okay? And I need you to pay attention to what I want to do today. What I want to do today is very, very crucial. Okay, so I'm actually going to share my screen, start with lecture first. Like I said, I'm calling this our final meeting. Of course, today is going to be the final meeting. Okay. Now, what I have for you, like I said, what I'm going to start with is multinomial logistic regression. We have not finished this, and I promised the other time, I'm going to go over the multinomial logistical regression. And after that, then I'm going to talk about, we're going to, I'm going to walk you through some areas also that are going to be part of the final exam. So let's get started. Like I said, I want to welcome you to multinomial logistic regression. Before now, we started logistic regression. I introduced logistic regression. We started with a binary logistic regression. In the binary logistic regression, of course, we believed levels, got two levels, and the levels that's the levels of the response variable. Okay, we use binary logistic regression when you are looking at a relationship between a categorical response that have two levels with other predator. From there, I walk you through what we call the analysis of categorical variables. Okay, we computed the idea of odd ratio, and from then I also walk you through how we can also use logistic regression in that regard. Then from there, I move to other variants of logistic regression that are actually called ordinal logistic. In the ordinal logistic regression, we got more than two levels, but they are ordered. I remember I gave you an example of political philosophy. Okay, when you go from liberal to moderate to conservative, that is being ordered. And I also give you an example when you're trying to look at the customer satisfaction. Maybe you want to know how satisfied is your customer about the product or your service you render. Of course, I know you're gonna that will be on a Richter scale that you're gonna have strongly disagree, agree, strongly agree, and stuff like that. So those are ordered. But what is new today? I'm gonna say what is new today is basically when we have situation where the response variable is actually more than two, but they are not ordered. In that kind of situation, we're going to use multinomial logistic. Oh my God. Look at the word multinomial. It means you got so many levels more than two. Okay, what levels are we talking about? The levels of categorical variable. Okay, so of course, I gave you, there's a lot of examples on multinomial, race. Race is an example. Race is not ordered. You know that? That's not ordered. Well, we got white, the black, African American, Asian, and so on like that. Okay, that's an example of multinomial. What about discipline? Okay, what about discipline? Okay, that's another example of multinomial, we have humanities, social sciences, and so on like that, those are not ordered, and that is basically going to be multinomial. Okay. Um, okay, so I think I just gave you an example of that now. Now, I'm trying to show you the statistical model for multinomial logistic regression. We use logistic regression when um, we got a categorical response, okay, levels more than 2, and they are not ordered. Okay, we're looking at the relationship between that and some explanatory variables. Don't forget, I told you the other time, okay, that with the moment you're looking at that, we're actually going to have a way to transform the the levels of the categorical predictor to a continuous scale that will be unbounded. You get what I mean, right? And of course, we need a link function. Okay, the link function that we're actually going to use will be other than identity. We're not going to use identity. I told you the other time, identity as a link function. We use that for general linear model. But when we want to talk about generalized linear model, okay, of course, we actually going to use a link function other than identity. And that's why you can see the link function we're using here. That's a log. Oh, take a look at that, okay, which means in multinomial logistic regression, we still use log. Oh my God. When you take a look at what I have now, with this link function, then we now have the relationship now between the predator and the response now is now being linear. Okay, that is after we've already incorporated the link function. Okay, so I'm going to give you an example on multinomial logistic regression. Okay, an entry high school student make program choices. Among program, we have general program, we have vocational program, we have academic program. Of course, these programs are not ordered. Does that make sense to you now? They are not. Okay, you know what I mean? Not ordered. They are not ordered. Okay. That, like I said, there's no program that is, that has a numerical advantage than another program. That's what we mean. And you know what? If we're now trying to look at the relationship between some explanatory variables and this, okay, then we're going to use a multinomial logistic. Take a look at this. Their choice might be model using their writing score and socioeconomic status. You know what we want to do now? We basically want to predict, okay, the program, and then, entering high school students will choose, okay, whether they're going to choose from general program, whether they're going to choose from vocational program, whether they're going to choose from academic program. That now depends on two predator. What are the predator? The writing score and the socioeconomic status. Okay, now I'm actually using the data set from the University of California at Los Angeles. Okay, they got this data. If you want to have access to the data, of course, that is a link to get the data. They already collected the data. And of course, you know what we want to do now? I want to read the data into R. Okay, the moment you copy all of that into your R, automatically, you basically gonna see the data set. By the time you actually attach that and you run that, you're gonna see the data. And you know what? There's something I actually need to tell you. Now we can generate table, okay, with the data. Now, if you take a look at the table that I have now, okay, this is more or less like, cross tabulating the program type with the socio-economic status. Okay, now if you take a look at this 16 now, it means entering high school students who actually come from low socio-economic class. Okay, choose 16 of them choose general program. Okay, 19 of them choose academic, and 12 of them choose vocation program. And that actually go all the way to this guy here, the one I circled now. Okay, the entering high school student in the high socio-economic class. Now, 9 of them choose general program, 42 choose academic, and 7 choose vocation. Can somebody confirm again if you are still hearing me clearly? Is everyone still hearing me clearly?
Yeah, we can hear you.
Thank you so much. Thank you for confirming that. Okay, now I if I want to run multinomial, logistic, in R, oh my God, I need you to pay attention now. I'm actually going to install that packages and net. After that, I'm actually going to load that. Okay, now this is where I needed to pay attention now. I needed to pay attention now. We got 3 levels, right? We got the 3 levels of, response, the categorical response. We got academic, we got general program, we got professional program. Yeah, you know what we're going to, or vocational program. You know what we're going to do? We need to, out of the 3 levels, we need to make one reference. I'm going to say that again. That is exactly what I'm doing here. Take a look at this guy. Okay, what I'm doing there now, I want to make a particular program reference. Making a program reference does not mean that program is inferior. No. And that doesn't mean it's superior. No. You can decide to choose any level of categorical response. You get what I mean? So right now, I decided to choose academic. When I choose a level as a reference, automatically, automatically, when you go into the outputs, you are not going to see that particular level that you reference. You're going to see the other levels. But let me tell you, when you want to make a decision or when you want to interpret the other level you see in your output, that will be relative to the one you reference. Now, I want to run the code now, after actually making the reference now. Take a look at this now. Okay. I wanted to take a look at that now. Okay. Uh, okay. I want you to look at that. Now. Give me 1 second. Okay. Now I want you to look at that now. You can see now. I'm actually, trying to relate, you know, the program. This is the response. This is the socioeconomic class. This is the right. Then it has to be multinom. Look at that multinom. I remember the other time when I was walking you through ordinal logistic regression is what polyar. Okay, but right now it's actually multinom. Take a look at that. It's actually multinom. And when I run the code, okay, when I run the code now, this is going to be the result. This is the output that came out in R. Oh my God. I told you the other time, you're basically going to see the other 2 levels. Don't forget right here, I actually make academic reference. Okay. Now you're not going to see the one you make as reference in your output. Okay, now we're going to get to types of output. There's going to be the coefficient side, and this side is the standard errors. Okay, there's going to be coefficient side. There's going to be standard error side. Okay, is there anyone want to ask question? Is there anyone want to ask question? Is there anyone who want to ask question? Is there anyone uh who need a clarification? Okay, can you still confirm if everyone is still hearing me? Is everyone still hearing me?
Yeah, we can hear you.
Okay, so I think I'm actually waiting, if there's anyone who asks any question. Okay, now if there's nobody, then I'm actually going to move. Oh my God, now that I have my output now, how am I going to write the module? Like if I want to write the fitted module or I want to make any interpretation, how am I going to do it? I'm going to show you now. Take a look at this. I'm actually going to have two modules out of that. Where am I having two modules? Because in my output is just going to be two levels. Okay, why the other one that was referenced is basically going to be in the denominator. Oh my God, oh my God, this is the module now. Take a look at that. That is the way the module is going to be. Take a look at the first module. You're going to see the log of the program general divided by the log of the program academic. Don't forget, the academic one was the one you reference. And that is the one that is going to be in the denominator. Take a look at this guy too. The academic one will be in the denominator. Take a look at that. Now, do you know that all this guy now, all those values, okay? Those are the ones that you have in the table here. Oh, give me 1 second. Those are the one you have in the table here. Like this is for general now. Okay, take a look at all of that. Okay, I'm actually gonna, you're gonna, and can somebody, do you know another reason why I'm having this? The predator also has one of the predator socioeconomic class has three levels. Okay, it has low, middle, and high, and R has automatically coded, low as 0. That's why you don't see low. Low is being referenced. The same way academic is referenced, but we are the one that we actually reference academic, but the arrow automatically reference low, okay, as part of the predator. Does that make sense to everyone now? Okay, so that is the way that actually goes. Now, just like what you have in the other logistic regression model, all these values here, they are also called log odd estimates. They are also called log odd estimate. Don't forget, log odd estimate. Okay, now if you want to interpret, for instance, you want to interpret 0.058, you want to interpret this guy. Okay, if you want to interpret that guy, 0.058 that to 3 decimal, that would be for general, right? How will you interpret that predator for general? This is the way you're going to interpret that. You're going to say a unit increase in the variable right is associated with a decrease in the log. Why do I say decrease? When I say negative, then I have to mention the logs of being in the general program versus academic program. Okay, this is general program. This is what we're interpreting. Okay, we're going to say it decreases the log of being in the general program versus academic. The academic was the one that you reference. Does that make sense? So that's the way you're going to interpret every one of that. Take a look at that. I provided interpretation here. The same thing that you're going to do for the other one. Okay. Now, I need you to pay attention to this guy in case you want to interpret categorical predator. How you going to do that? Like you basically want to interpret 1.163. Where do I get that one from? It's actually here. You see that? For general, okay, to 3 decimal is actually negative 1.163. That is socioeconomic class I. If I want to interpret that, I'm going to say moving from the low socioeconomic class to high socioeconomic class. That's what I'm going to say. Because the low socioeconomic class is actually being referenced automatically by R. And that was why we got this. Take a look at that now. It said the logo. Take a look at this guy now. the log of being in the general program versus academic will decrease by that if moving, okay, from low to high. Okay, anytime you want to interpret, anytime you want to interpret anything that has to do with this guy, okay, you're actually going to be mentioning low, moving from low. For instance, now, if I want to interpret this guy now, okay, I'm going to say, moving from low to middle class, okay? So there's going to be an increase. The log for choosing the vocational program against the academic. Okay, take a look at that. And that is how we actually interpret all of that. Is there any question about this interpretation? Is there any question about this interpretation? Okay, which means everybody is good about interpretation. Now, there's something I wanted to say. It doesn't come with a p-value. Okay, the multinomial logistic doesn't come with a p-value, as you can see right here. Okay, in case you want to test how significance is one. But that's not what we're interested in. If you really want to compute the p-value, then we basically need to use a Watt test. Okay, but you know what? You don't need to worry about that. This is going to be the end of the lecture for the semester. And what I want to walk you through now, I want to go into revision. Is there anyone who want to ask question before I go into revision? I need everyone again to confirm if you're still hearing me clearly. Is everyone still hearing me clearly? Okay, somebody raise up. Okay, go ahead. Person that raise up a hand. Go ahead.
Hey, I don't know if you said this already, but will there still be office hours this week by any chance or no?
My answer is yes. There's going to be office hour this week.
All right, thank you.
You're welcome. Okay, now I'm actually want to welcome you to revision class. And I want to tell you what you need in this final. You know, in this final, of course, you know, the final is going to take place 8 to 10 a.m. Tuesday, May 9, as you can see. And of course, I want to confirm to you, there's going to be 15 multiple choice, 15 multiple choice, okay, and 3 short answer, okay. And you know what? All of them will revolve around 3 major topics, okay. They're going to be 15 multiple choice, okay. In the 15 multiple choice, you don't need to explain anything at all. You just need to choose an appropriate answer for that. It is only in the 3 short answer that you actually going to explain. And let me also confirm to you, you need R for this exam. There are 3 questions and I'm actually going to set the short answer, and I'm going to tell you right now, there's going to be one particular question that you need R software, and you need to come to the class, to the exam hall with your laptop. You're going to need laptop. Okay, I'm going to say that again. In this exam, you need R for one problem out of 3. And I'm going to tell you which one you're going to need R for. I need to confirm again if everyone is hearing me clearly. Is everyone hearing me clearly?
Yes.
Thank you so much. I'm going to repeat myself. There's going to be 15 multiple choice question in this exam, and there will be 3 short answer. All the questions in this exam will revolve around 3 areas, which I'm going to mention now. Principal component analysis, repeated measure ANOVA, logistic regression, and its variants. Now, let me tell you this. In this exam, where you need R here in logistic regression. I'm going to say that again. Where you need where you actually need R, okay, you actually need R here. I received a text now from somebody that whether the exam is going to take place in the regular classroom. I've already sent a message to Office of Classroom Management to ask if whether the plan has changed. Up to this moment, my understanding is the exam is going to be in the class that we used to have a lecture, but things can change. But if there's going to be any change, that I'm expecting their response, and that will be communicated to you, okay, latest Wednesday, since your exam is still May 9. Okay, I think I'm actually responding to somebody who's just sent me a message right now. Okay, now I basically want to confirm this again. There are going to be 15 multiple choice, and there will be 3 short answer, and you need R, your software, for 1 question, and that very question is going to be on logistic regression, okay, on this particular area. Okay, that is where you need R. But let me tell you, let me just revise with you what we did in this area. I remember we did binary, logistic, okay, we did analysis of categorical variable, analysis of categorical variable, you remember the one that involved a case control study, right? Okay, and I walk you through ordinal, logistic, and multinomial. But you know what? I'm also going to tell you here, the one out, if you take a look at all this is the area that I'm actually want to use where the R is going to come in. In the other area like PCA, repeated measure, you don't need R. You don't need our software. I'm going to say that again. In this exam, you need to bring your laptop. You need R for only one problem, just one problem. And what is the problem? The one under this area. Okay, it could be binary logistic, it could be, so it's going to be just try and practice what you did in this area. What I'm actually going to tell my TA to do tomorrow is to ask my TA to walk you through this area. Since this is the area you're going to make use of R, I'm going to ask my TA to do revision for you using the binary logistic, analysis of categorical variable, the ordinal logistic, and the multinomial. Okay, now, like I said, you need R here only for this problem, but repeated measure, principal component, you don't need R. I'm actually going to provide you an R output here. Okay, you only need to answer a question. I'm going to provide you an R output. You only need to answer a question. Talk about the principal component, talk about repeated measure. But for this guy, you're actually going to make use of your laptop, your R software, because the exam is going to be 2 hours. Okay, now the next thing I want to talk about now, I want to revise with you. Okay, somebody said, are we supposed to have lab tomorrow? I'm going to ask for my TA. Oh, today is the last day of instruction, right? I think I'm going to ask whether if today is the last day of instruction, and if that will affect the lab. But if it affect lab, it's just going to be simple code, the one you've done before. I will need you to revise your lecture note. Okay, the code that you need for this exam. You know what I'm actually going to advise. Okay, you know what I'm actually going to advise. This is what I'm going to advise. Since I'm actually going to allow a two sheet. Why can't you write all the code in logistic regression? I'm going to say that again. If I were you, since I allow two sheet, write the code that in your lecture note for logistic, for the area of logistic regression. You can write it down. So by the time you come into the exam hall, you're just going to modify that. Is everyone still hearing me clearly? Is everyone still hearing me? It's like
Yes.
people are, oh, thank you so much. So like I said, somebody said, when will the solution of practice and exam 3 be? Okay, let me tell you, I will post that solution today. Okay, thanks for reminding me. I will, in fact, immediately after this lecture, I will post that solution to the practice, final practice 3. Okay, now, like I said, let me now come to the principal component analysis now. In the principal component analysis, of course, we use this when we realize we got a lot of variables, predictor variables, and they may be correlating. And of course, the idea is to convert them, okay, into uncorrelated ones. And not only that, we're looking for a way to reduce the dimensionality, right? Okay, if you want to, we don't ask you, when we construct a PCA, right? I want you to take notes. Okay, since you're not going to use R for this, but I'm actually going to provide you probably R output. You need to wash out whether do I use covariance matrix to construct my principal component analysis. Then you also need to check very well, pay attention whether I use correlation matrix. Is it correlation matrix or covariance matrix? Okay, please wash out. Okay, now how do I select my principal components? Okay, we normally have 2 ways to select the principal component. Okay, we actually have number 1, the threshold of at least 80%. Another one is when the eigenvalue greater than 1. Okay, but let me tell you this. Okay, when we are using correlation, okay, we can use eigenvalue greater than 1. We can use at least 80% threshold cumulative. But if you have a covariance, okay, if you have a covariance, I will advise that we should use the 80% threshold for covariance. Because if you use eigenvalue greater than 1, you may be misleading, because you can only use eigenvalue greater than 1 if your independent variable, your explanatory variables have the same scale. You may not know whether they have the same scale. And that's why, to be on the safer side, use the threshold at least 80%. But you know what I'm going to do? In this exam, I'm actually going to be specific. When I want to ask a question on this, I'm going to, okay, use the threshold. I'm going to tell you the threshold you're going to use. You are not going to be the one that will decide. I will be the one. I'm going to put it as part of the instruction that use a particular threshold. And you need to follow my lead. Does that make sense to everyone? If you get that information, I need you to give me a thumbs up, or you say yes, or you comment yes. If you get what I just said right now about the threshold. Okay, thank you so much. Like I said, I would be the one that would tell you what threshold to use for this exam. I will be the one that will tell you. Okay, now the principal component is kind of easy. Okay, don't forget, we got the eigenvalues, we got the eigenvector. Eigenvalues, they are the variances of the principal components. The eigenvector are the principal component. Don't forget, the principal component is a linear combination of the old variables. Okay, I wanted to really understand that. Okay, now the principal component is kind of easy, very, very easy. Is there anyone who want to ask question about principal component before I move to the next area of focus?
I have a question.
Go ahead.
For the PowerPoint at week 10, lecture 1, I think. Maybe could you please find that PowerPoint?
Yeah, what do you want to say about it?
There is a PC approach with some steps, and there are some member list. And for the member 8 and member 9 here, maybe I will send you an email.
Okay, so what can you just tell me what your question is about so that I can answer you now?
Also, at the step 9, there is a limitation said that for the transpose of age and AI should equal to 0, but here we need to have I less than j, but for the A2 here, it says that A1 transpose times A2 equal to 0, where in this situation, the 2 is greater than 1, so there may be a contract.
Okay. Do you know why you shouldn't worry about that? It's because you are not going to use R for principal component. For principal component, the arrow outputs will be provided for you. Do you know the only thing you need, right? You need just to answer question based on the output provided. Does that make sense to you now?
Okay.
Okay, now I want to go into the next area in the exam. Oh my God, this area, repeated, measure, ANOVA. There's a lot of activity here. Now, in the repeated measure ANOVA, particularly when you're talking about mixed, I remember a question on where we're looking at the effect of diet. Okay, not only that, we got weak. Okay, and the subject was actually cow. Okay, now when you take a look at what I have right now, you're basically gonna see that I think the response was protein in a way. This is response. There's actually a mixed ANOVA under repeated measure where you actually looking at the effect of diet. Not only that, you're looking at the effect of weight, because you basically want to see whether the protein change over time. Now, I'm going to use this as a typical example now. Take a look at this. I got protein, right, on, okay, diet, week, okay, plus, okay, 1 vertical bar cow. If you take a look at what I'm doing here, I'm actually using a random intercept. Take a look at this. Okay. Now I'm using random intercepts when I'm only looking at the main effects of diet and weight. There's going to be 2 modules for random intercept here. This is going to be the first one. The second one is going to be diet, okay, multiply by weight, okay, plus 1 vertical bar cow. That's another random intercept, except that here I'm talking about interaction. Here without interaction. Please pay attention to this. How do we choose the better model here between, I'm actually, this is going to be M1 is a simpler model, and this one is going to be M2, a complicated model. Interaction is always going to be complicated model. Okay, if you are actually talking about random intercept. The idea of ANOVA, nested ANOVA test can be used to choose. Don't forget, please revise that. Now, this is when I'm talking about random intercept. If I'm talking about random slope, this is going to change. Okay, if I'm talking about, give me 1 second. If I'm talking about random intercept and random slope together, okay, please pay attention. I'm also going to have 2 models. Okay, protein on diet plus week, okay, plus 1 vertical, plus 1 plus week, okay, and cow, okay. Then I'm going to have the vertical bar cow, okay. I'm actually going to have 1 plus week vertical bar cow. The one I ordered before was just one vertical bar cow. Okay, now putting week here, this is a random intercept and slope for without interaction. I'm also going to have for with interaction. Okay, then I'm going to compare them. Now, do you know that for random intercept and random slope, the best model you choose, you're also going to consider whether you have correlated or uncorrelated. The uncorrelated one, there's going to be 0 plus 0. The correlated one will not have 0. Please watch out for stuff like that under repeated measure, and also investigate the assumptions. Okay, not only that, you also need to study the error structure, the covariance structure, the compound symmetric, the autoregressive of other one, and unstructured. Okay, a situation where you are comparing the 3 and none of them, if one of them do not run, then that should be out. But anyway, you don't really you're not going to use R here. Okay, so it's just our output that will be generated. But this is where you're going to use our output. Are you going to use our software? Okay, now I want to believe you have actually you understand the areas that are coming out. Let me use this opportunity to appreciate every one of you. It has been very wonderful time You know, I've been highly privileged to be your instructor this semester. And I hope that, of course, you're basically going to succeed, you know, in your future endeavor. But what I'm just going to tell you, don't be scared. Don't let any situation pull you down in life. Okay. For those of you who have not scored A before, believe it is the time to score A, because the final exam has huge weight. The moment you follow my lead, the moment you follow what I've explained today, that exam is going to be a walkover for you. There are some students who submitted assignments, and uh, I think from tomorrow I'm going to be having time to go through assignment that is submitted before. There are some that actually seek for extension from me, and they submitted, and I asked them to submit to me. That I'm actually going to start grading those assignments from tomorrow. And those who submit before the deadline, of course, I'm actually going to grade those assignments tomorrow. And those who send messages to me, I'm actually going to start replying to the messages, because I have enough time to reply to everybody now. And of course, I'm actually going to have my office hour as well tomorrow, in case you need more classification. Like I said, in the exam, you need 2 cheat sheets. When I say 2 cheat sheets, it's just going to be one-sided, or 1 sheet, 2-sided. You know how it goes, right? 1 sheet, 2-sided, both side, or 2 sheets, 1-sided. That's what I mean. Okay. You know, the road to, just like what I used to say, failure in life is not falling down, but staying down. Somebody said, which week of the lecture is the first one for the exam 3? I may not, but I will advise that you go into where we start principal components. Okay, you go to the week where we start principal components. From principal component to the last day of lecture. From principal component to the last day of lecture. Okay, before I go, the road to success is narrow, and everybody want to pass through the narrow way, going by the accommodating capacity of the road. The road cannot take everybody at a time. Some will go, while some will wait. Who are those that will go? Who are those that will wait? But you know what? The whole world will step aside for a man who knows where he's going. When you know where you are going, when you are determined, the whole world will step aside for you. They're going to say, okay, you go, and you need to tell yourself, we continue to be in the race of success until I'm classified the best in the whole world. You can be the best. You just need your time. Take your time. You can actually score A, even though you haven't scored A before in statistics. But this is the time to score A. If you follow what I just told you today about, you know, with the area the exam we cover, oh my God, you're actually going to score A in this exam. I wish you very best of luck, and I'm going to see you tomorrow in my office hour. Make sure you stay safe. And oh, before I go, I'm actually going to make an announcement about the student rating, because the university is also requesting that. You're actually going to see that on Canvas, you know, where you're going to rate your professor. They need you to do that. They need you to tell them the way we are handling our work. That is good for the system. Okay, so that we'll be able to make some adjustment. Please make sure you do that. It's on the Canvas. Okay, until tomorrow and the day of exam, make sure you stay safe and have a lovely day. Bye for now, everyone.
Professor,
Yeah.
can I schedule a time with you?
Yeah.
On
Can you?
Wednesday or something?
Okay, on Wednesday, right? Yeah, you can send me a message.
Oh, okay.
Send me a message. I'm actually going to reply to that.
Okay. Thank you.
You're welcome. Okay, thanks so much, everyone. Thank you too. Bye.